Welcome back. This is going to be a long one. I'm pretty sure it's obvious by the length of the video. This is going to be a long video, but in this video I'm going to be trying to explain my parser. This is going to be really disjointed, and we're just going to get into it. I'm not going to try to entirely, I'm trying to show every function in this parser, and try to explain exactly how it works, but don't expect me to be perfect with explaining this. I'm doing this all in one take, and I'm going to try to do this on the first take because I don't feel like spending multiple hours recording this. I'm hoping to keep this under an hour, but, you know, let's get into it. So I've shown this previously and talked about it in passing, but now it's mostly done. It cannot parse arrays just yet, but otherwise it's done. It also doesn't have any escape character support at all, so it kind of gets messed up if you enter some characters in specific spots, but otherwise it works pretty well. Let's start out by entering just something. Let's say, or I'm just going to do A and then B, and then let's do an object with a name of C, and within that object we will have, I don't know, we'll just do something, and then we'll make it a number. So hopefully that should be correct. That's A colon B comma C object something 1 2 3 4. Yeah, okay. Just have to make sure my JSON's correct, or else this entire thing will fall apart. It does require properly formatted JSON to work, otherwise it parses incorrectly. So we are going to do function misc, and we're gonna copy from our book here, and as you can see we have A, B, C something 1 2 3 4. Let's go ahead and run our parser on it. So function parser call, and that'll parse that, and we get data get storage parse main out. And oh whoops, I forgot to do the proper call for the parsing. I copied from the wrong thing, so we'll do misc parse from ASCII, and then we will get that again. So this is the proper thing. This was still using the same input value as last time, so that's why it was freaking out. So as you can see here, we have value, and then value again, and then B, type string, extra name A, and then after that we have value 1 2 3 4, type number, extra name something, then type object, then extra nothing, name C, type object, name main. That's kind of confusing to read, but that is parsed output. Basically what's happening here is this curly bracket here is this curly bracket here. So this value right here corresponds to this name here. The big issue with this that I cannot control is it outputs as value. Then we have our value, and then we have our type, and then after that we have our name. Our extras right here. Extras just data for whatever I may need to. It's basically for markers. I may or may not have that get deleted in a final pass afterwards. I might have to use it for arrays. So for now, it just stays in the object, or in the name value pair object. But that's how it parses. Now if we parse something a little bit more complex, let's go ahead and parse my own head here. We will do misc parse skull. This runs TS's string thing, and then it runs my base64 converter and copies it over to the ASCII out, I think, or no, this parses the skull, right? What did I run? Parse skull? Yeah, okay, so this is going to do all the parsing for me. So we just have to sit here and wait for this to run, and then we do /data get storage parser main out. And then we have our parsed skull here. This is really hard to read, but it's there. We have the URL for my cape here, and then the URL for my skin here, my profile name. It's all there. It's just really, really hard to read. This parsed output's not meant for a person to read. Let me actually show a command. Do I have it in the world anywhere? I don't think I do. Let me go ahead and let's see. So what's supposed to, let me switch over inputs. So what's it's supposed to be doing here is you read it from something like this, just a long sort of data call there. That's sort of how you're supposed to be able to read it. As you can see, we have name main, then dot value, and then name textures, dot value, name cape. So this is sort of how it's supposed to be read by a thing. Really, a player or the user's not supposed to read this. This is supposed to just make it so you can detect for certain names or values within your pairs. But that's sort of how you read that. You're not really supposed to read it because it's hard to read. I will admit that this output's a difficult to read thing, especially because it is an input from a char array and I can't flatten. If I could flatten strings, this would be a lot more readable. But since I cannot flatten strings, then this is just a difficult to read thing. So yeah, that's how that is. If I could flatten strings, this would be, as I said, exponentially easier to read. But for now, it's this. You're not supposed to read it really. But I guess we'll go ahead and get into the functions. It's spooky. So we got our parser here. I do know, by the way, I know this is spelt wrong. I spelt it wrong in the start, and I was already quite a ways in before someone said that it was spelt wrong, so it's a little bit too late to go back now on my mistake. So yeah, that's just a whoops on my part, but it doesn't really interfere with anything. So right here, these two folders, we have my base converters that I've showcased previously. Right here we have some quick call functions. These are to just shift some stuff into registers and they're not really named. They're just so I can type /function c to c, c nvc, and c oec for whenever I need these, because these are utility functions. They're basically just to easily run this command or like these two commands. It's an ease of use thing. That's what those are for. So we'll ignore those. I know what they'll do whenever we get there. So whatever. And then in the Minecraft folder here, we just have a function tag that runs the setup. We don't need to look at that. So now on to the actual bulk of this. And this is the, what are we looking at? How many files do we have in here? 39. We have 39 functions we got to look through here. It's quite a few. So I guess we'll get into it. So you start off by running the call here. Actually, yeah, I'm not going to get into it. I was going to talk about how the parser parses data similar to how Minecraft stores JSON formatting, which is what this is right here. This is how Minecraft stores JSON formatting. It's kind of a nightmare to look at, but it's how it's stored, but we don't need to look at that. So we start out with our initialization, which does some data setup into our parse main, and then takes the information from parse in and puts it into the mains in slot here, the main in array, and then we add this string of characters here. We add end to the end of the list. This is just so I know whenever I actually hit the end of the array, just in case there's a improperly formatted JSON or something, it will just self-terminate. It'll stop trying to parse any information out of it, as well as just a general end marker. So that's what that's for. And then next we have parser initialization here, init, I guess you can call it as it be. And then in the init here, we look for a valid JSON start. This is just looking for a curly bracket at the start. C to C right here, basically, as already shown. Let me just open it again. So we'll go back to parser data C. And C to C, this is the one we'll be seeing a lot of. It takes the first entry, basically the first character in that in array, and places it into the check value. Now the check value is a very important slot. It's so I can basically do this to look for a character. All I have to do is open bracket or open curly, closed curly, and then check colon, and then inside of quotes the character that I'm looking for. That's all this does right here, is move that first character into the check slot. So that's what that is. If the first character in the array is an open curly, then it knows that it is safe to start. Otherwise, it could potentially cause issues, and also just in case you try to run something that isn't JSON through it or whatever, it will just refuse to run, basically. So next in our call function here, or next in this, is parser start. So this is where we actually get into the bulk of our stuff. So functions and then start. Now this is a looping function. We scan for name start, call a name value pair. This is where the bulk of all processing happens, right here. And then we check for the end string. We'll look at this function next because it's just a simple little function. Check for end right here. Sets that first value. This basically does what C to C does without clearing that first slot. And if it matches end, then it knows that it should not. So unless that data matches end, go ahead and run this function again. So this loops. So next we have scan for name start. I keep going over to the wrong monitor. Scan for name start goes ahead and looks for a quote. So clears out data until it finds the next quote. So we run our OEC. Let me actually go ahead and duplicate this just so I have easier access to data C functions OEC. This goes ahead and execute if data storage parse is a closed bracket. It marks the it adds object end. This is for later. This basically makes it so if there is a closed curly bracket, it says that it is clearly the end of an object that we're at whenever we're scanning for a name start. And then execute unless data storage is a quote. It will run name start retry. Now, let me move this out of the way. Name start retry just does C to C and then reruns the scan for name start. And then it redoes this, and it basically, as I said, this loops. If it finds an open curly, which is what OEC is here, it will mark an object end. If not, it'll just keep going until it finds either the end object, as you can see here, or it finds a quote. And then it will go ahead and run on to the next thing. So we're on start. So once it finds a name start, it'll end that loop. And once we've ended that loop, we can go ahead and start running our call NV pair. Now this is the bulk of the parsing. So let's go ahead and just close scan for name start OEC and name start retry. So next is call NV pair. Call NV pair here is a set of functions that need to run in order. So we start by generating pair. So generate pair. Modifies into parse main pair. It will set it to this value, which is the name, value, type, and extra. This is just so I can write to the name value pair, and that's all that generate pair does. Next is copy / name. So copy and name. This runs C to C, and as the comment here says, it will copy the name of the pair until it hits a colon. So this will go ahead and C to C. Unless that data matches a colon, it runs transfer name char. So if we go ahead and look at transfer name char here, execute unless. This just makes it so quotes aren't copied into the name array because it kind of clutters the data. I'll make something with escape characters. As I said, there's no escape characters right now. An escape character will bypass all of the transfer name checks and all this and just copy the thing that's after the escape character directly into the value that it's copying. But that's not important right now. It goes ahead and appends. This just takes that. So after we C to C, that shifts that first character into the check array or check object or check entry. I don't know. And then we are just appending that into our name value in our generated pair thing here. So it just places it into this array. And then we go ahead and rerun copy/name, which is this. And then once it does hit a colon, it will then, it will take that, or once it hits a colon, it'll then stop running that. So then this is done. Next, we go ahead and do detect type. Now this is a semi-important function, so we're going to go ahead and clear these out. We've looked at all that. Next is detect type. Now detect type here this function detects what type of value the pair will be using. Default is number. As you can see right here, it just starts out by generating a number. This right here sets the check value. This basically just copies the first slot into the check value. This down here, if the first or the character it's copying is a space, it'll run detect type retry, which just does C to C and then reruns the detect type here, and then it just reruns all this. Now its default is number, because if it wasn't a default as number, I would have to check for all values for numbers, so 0 through 9, which is kind of annoying. So instead, I just override if I detect a quote, open bracket, or a curly bracket, and that is a string, array, and object, respectively. Now, after we detect the type, we'll go ahead and clear those out. We then do type call. Now this is a conditional function that does, so where's that at? It's going to be type, I cannot read suddenly. Where's that at? Copy type call, that's why I cannot find it. Copy type call. Now if it is a string or a number, we go ahead and run the basic copying, which I'll get into here in a second. And then if it's an array, it does copy array. Now as I said, arrays aren't supported, but they do copy. Arrays can copy. They just copy unparsed data. It just copies all data from the open bracket all the way to the closed bracket. And that it doesn't parse just yet, but it does support arrays to an extent. But we're just going to look at the copying of basic values here. So that's what type call does. It's just basically a conditional thing, as you can see. So next we have our copy basic value. Now this does C to C. This just copies the name, or whoops, this should be copies the value of a pair, but I just copied this from the thing and did some modifications, so ignore that. We'll value of a pair. Just act like you didn't see that. Run C to C. Then if that is this is confusing me. Oh, right. This is a thing to fix an issue. Basically, if it's a closed, I'll see if I remember to talk about this. I will, but this is just a simple solution to a problem that I was having. So just ignore this here. But basically, we're checking, we're running as long as there's something in this open thing here, unless we hit a comma or a curly bracket, we're running transfer value char. Let me save this. I'll update the GitHub repository later. This then copies that unless it's a quote, for the same reason as why we weren't copying the quote for the name thing, is it just dirties up, and if I need quotes for anything, I can just prepend and append them to the name and value array, but I don't need them otherwise. They just crowd up the data. I copy over that into the value array. As you can see here, main pair.value, I append it from the check value, and then I run again copy basic value, and this repeats until it does find as you can see, unless here, unless it finds a comma or a closed bracket. So after that, we then are no longer running this. We then go to type resolve. So let's go ahead and switch over to that. So copy / type resolve. Now this, depending on a number, an object, or an array, we will add array notes, object notes, or do some extra processing for numbers. So let's start off with number. Actually, no, let's start off with object and array notes. These are the simplest of the two. So we go to functions extra, add object notes, and add array notes. This right here just adds unresolved to the extra array, which I shown earlier with, if we go to functions and generate NV pair, where's that at? Generate pair, into the extra array here. All it does is add unresolved to that, and I'll get to what that is for later. That is for here, for object condensing. And the same thing happens to arrays. It just leaves them as unresolved, as well as it checks to see if there's an open bracket at the start of the array's value, and if there is, it removes it. And then this right here just resets the data back. So basically, whatever. This is just to prevent any potential issues. So next we have, so after that we have our notes there. We then have the number resolution. So in extra / number, we have converting the char array into an array of numbers. So this right here, since all inputs into the system is an array of characters, numbers are just characters in quotes, but I need the numbers to actually be integer values, which they're not. So what I'm doing is I'm running this num array convert, which is right, is it just extra num array convert, which is this right here. So shifting the current number to the check register, which I do whatever, and then we have converting the character to a number and then storing it in the temp array. So nacchar to num is just if that value is 0, it adds 0 to the temp.array. If it's 1, it adds 1, and so on all the way down. And this is just converts this quote number into an actual number. And this will repeat until there is nothing left in the name pair value. Then after that, we let's see, so num array convert, that's what this is here. Next we do the extra num check. Now this is, let's see, are we actually, yeah, okay, this loops, never mind. So once that's done, it runs this next or extra and then num check. Now num check, if there are less than 10 values, so basically if the this is just a simple way of testing if I can convert the array of numbers into an integer or not, because otherwise the scoreboard calculation, this uses my base x to decimal converter, which I'll just show how that integrates here in a second. It'll flatten the number. If not, it will run long num here. So let's go ahead and look at long num, which is this. It sets the value, or the main pair.type set value to long number. So this changes the value, or changes the type of the number from just number to long number. This is because long numbers cannot be easily added to the scoreboard because they are arrays of single digits instead of just one number that I can more easily copy using execute store or whatever. So it sets the type to long number, and then it just copies the storage, or sets the value of the pair to that temporary array where we were writing the numbers to. So that's what that does. But if we can flatten it, we go ahead and run num flat right here. Now this takes that temporary value and places it into my input of my reverse, my base x to decimal conversion, sets the base to 10, and then we go ahead and run the call for that, and that just flattens those values into 1, and then we modify the storage from our output value into our the value of our pair, and that's so it's just a number. If I look right here, as you can see, this right here is just a number, and then this right here is a long number. So that's the difference there. So let's go ahead and get all these back open. Give me a second to find it. That's the wrong one. It's the second to last, I think. Nope. I have a lot of folders open at the moment. That is also not it. We will find it eventually. That's also not it. That is not it. It's going to be the last one. It was the last one. Wow. So there's our number flattening function, and our num check function, char num array convert, and number. So that's all of that is just to flatten numbers. That's just basically to parse the numbers into a more easily or a more proper format. So that's type resolve. Now we have write name value to out. So let's go ahead and look at that. We just have functions and then write nv to out. This writes the finished name value pair to the output array. So this, if no name is found for whatever reason, it will not copy or will not move this value or copy the pair into the output array. So if there's somehow an issue where no name is generated, then it just ignores that name value pair and moves on, because clearly something went wrong. And then we are just resetting the pair value. So that is that. Next is COEC. This also checks for the end of an array at object end check. Sorry, it looks for the end of an object, and then if it finds one, it will add that object end to it. That's just a second check. It's the same thing that happens whenever we do the start here, or the check for end or whatever. So once that's done, we are back in the start function here. So that's the call nv pair. Then it checks for the end, which I've already shown. We'll look at it again, just to reiterate. Check for end here. This just looks to see if there's an end value after checking the current space in the in array. So let's go ahead and close all these now that we're done with them. So now that we're done with start, this will loop until there's nothing left in the input array. Once that's done, this init function here will be done because we just run the start here, and then we start doing object condensing. Where are we at in the video, by the way? 28 minutes? Not too bad. I was expecting to be a lot further behind. This is where we are taking, where I talked about the I talked about generating this. This is what this right here. So if we go to call, that's what this is for. So let's move on to what this is for now. So it's res, yeah, okay. So we're moving up to, oh my god, I didn't mean to close that. We're moving on to the resolve thing here. So we start out by doing pre-resolve, which is right here. This goes ahead and resets the temp out and temp object arrays in the parse object storage space. And then we are what's this? I just programmed this morning, so I was kind of in a just tunnel vision trying to get this done this morning. This adds the main name value object pair to the beginning of the output array in our main storage space, which is just value type object extra unresolved, which is what we'll be looking at next, and then our name, which is main. So now we're getting to the point of having these. Actually, I didn't talk about something. Let's go back for a second, and let's go to copy type call. Now, if you look here, we have string, number, and array. We do not have object, and the reason for that is objects I don't do anything with. That's why we're detecting for the end of an object by looking for a curly bracket. If we find a curly bracket, we add this entry here, object end. So basically what that leaves us with is something like this, where we have something type object with its name, which is filled out properly, then an empty value, and this extra unresolved value. That basically means I have somewhere an open curly bracket that has a name on it, and then somewhere along the line we have a closed bracket. So this is probably where this gets a lot more confusing, because this took me a while to figure out. I actually have some notes here that I'm not going to try to explain. Well, should I? You can pause and try to understand this. This is my notes. This is my map for how this is going to work. But we're just going to go along here. So this right here looks to check if in our output array we have both an object end and unresolved objects. If both return true, then we run resolve objects. If for some reason at any point, this is also the same thing that I use. Let's open up resolve objects here. Functions resolve objects. This is the same condition I use to loop this function. For some reason, there's an extra unresolved object or an extra object end, it won't try to parse it. It just will give up on parsing those if for some reason there's an uneven amount. So this is our resolve objects here. This is a list of things that happen. This right here searches for the first available unresolved object. So we'll go ahead and scan for unresolved. This right here does CNVC. Let's go ahead and open up, I think this one. Yeah, NVC. This right here shifts the current end. This basically does what CTC does, but for things in the output array. So this shifts that first object into the check register. So we don't need that. So we just shift into the check register. And then if that, so unless that object is an unresolved object, we retry. And the retry function here is, scan for unresolved retry. Goes ahead and it moves the check value. It prepends it into our temp out. Now this basically makes it so we are taking the output array and writing it in reverse into the temp out array. And we keep doing that until we find an unresolved object. And once we do, we then move on to the do resolve. Now this is the heavy lifting of it. I'm getting sort of anxious because this is the more complicated part of this, because this is way more crazy than the rest of all this thing. This was the part that I was having trouble with. The next more complicated part than this is the array resolution, which I'll have to do some other time. I need to take a break from this project once I'm done recording this video, basically. but we have do resolve here. Now this goes ahead and places the value in the temp out, or the check array, which is always going to be if we found an unresolved object. So what we do is we put that into the first slot. So we prepend it into the temp out array. So now we know for sure that we have an unresolved object in temp out 0. Next, we go ahead and fill that temp object. So let's look for fill temp object. We now shift entries from the out array into the temp object array until either an object end is found or another unresolved object is encountered. That's a lot. That happened very quickly. A lot of words I just said, but I'll try to explain them. So we are shifting our entry into our check register, which is NVC there. And then if we find another unresolved object, we run this here, which is new unres found. So new unresolved object found. But this here will loop. This doesn't happen unless we find another unresolved object. So for most of the time, we're just going to be, unless we find an object end, we are going to be running pair to temp object. So pair to temp object right here just modifies storage. Sorry, I'm getting blanking. I'm freaking. It's getting complicated. It doesn't look complicated, and also I'm tired. So whatever. We are taking the thing in the check value, and we are placing it into temp object, and we are appending it because we're putting this in order. And then we are running the fill temp object again, and we keep doing that until we either find an object end or we find another unresolved object. Now, if we find another unresolved object, something else happens. So this is where it gets funky. So we are running, what function are we running? New unres found. So new unres found starts by dumping all. So we have temp object dump. Execute if data parse temp object 0. So if there's something in the temp object, we will run this just in case we find another unresolved object immediately after that first object. So if we have stacked objects, just a bunch of them, then this will run like immediately. Otherwise, it will do temp object dump. Now, temp object dump takes everything. This shifts the entries from the out array into the temp object array until either an object, or wait, what? Oh, whoops, I selected the wrong one. Where is it at? It's going to be dump, temp object dump. Here we are. Sorry, I clicked the wrong one, so I was getting confused. Moves all entries from the temp object to the temp out in reverse order. This is just takes this. Then this is the same thing here. So this will loop this function until there's nothing left in the temp object array. And this just moves it in reverse order. And we'll get to why we're doing it in reverse order here in a second. Or here in a minute. I don't know. It'll be a while. And then once that's dumped, we then do the do resolve again, which is this. And this is the same exact thing that I explained before. And then this repeats fill temp object, and then this keeps going until either it finds the end of an object or another unresolved object. Then that will repeat over and over again until it finally finds an unresolved object that has no unresolved objects within it, and then it goes until it finds the object end, and then it will run our next thing, which will take our temp out. Let's see, shifts data from temp object to current object being resolved and marks object as resolved. So this right here, temp out 0, as I already said, we know that there's an unresolved object in temp out 0. So we are taking that temporary object that we were generating and placing it into the value array for that. Next, we are just clearing our temp object array because we no longer need that. And then we are removing the unresolved note from the thing, this is just 0, 0 because I know for sure that objects will not have any other notes. If they do, I'll change this, but for now it works, and that's all that matters. And then next, after we do all that, after we've finally resolved an object, we then run return pairs. So return pairs goes ahead and this loops. So execute, this is our loop condition here. If there's anything left in the temp out array, we just run this function again. And what we're doing is we are basically taking that reversed array and re-reversing it back, so we have in our main storage out, we have our list of pairs back in the proper order once this function's done running. So that's what that does. This just returns all those pairs. We'll go ahead and get rid of all these. And then we will loop if any unresolved objects remain. So this will run over and over again until there are no unresolved objects and object ends within our out array. And that is it. That's how it works. In our start here, or in our call, that's the last thing that runs, is our pre-resolve function. That's all the object condensing. After this, I would probably run array condensing, or I mean array parsing. But as I said, for now, that's not supported. I don't have that. That's something I'll be working on in the future. But for now, we have objects, numbers, and strings are parsable by this system. So that's it. That's how it works. Hopefully that made sense. I'm hoping that made sense because I'm not going to try re-explaining it. This all will be in a GitHub repository in the description down below with the rest of everything else TS and I are working on for this project. The whole goal of this is just cape detection. Kind of. Because something we can do, as I've shown before, we can detect a cape on a player, which is useful for one thing and one thing only, kind of. We can also see if a player has an Alex skin model, if we need that information, because in the metadata of a player head is if a player has an Alex skin model or not, as well as the cape and what their skin URL is, so we can also check if a player's changed their skin from the last time they logged in or something. But yeah, this has its uses. People constantly ask me and TS why we're doing this, and our answer is there will probably find a reason eventually. But for now, we have our use, which is detecting capes and stuff like that. I mean, we can do a bunch of stuff with it, but yeah, that's the Json parser. Thanks for sticking around. Thanks for watching, I guess. For anyone who's actually sticking around this long to watch me ramble and try to explain this system. This honestly took a lot less time than I was expecting. But yeah, thanks for watching, and I will catch y'all next time.